All right, so here are the practice examples 3 and 4. Let's see how you did. Okay, so I am analyzing my two-way table here. I do see the total row and the total columns, so that's good. No extra work to do. Okay, so is a late arrival independent of the flight being an international flight? So I'm going to say late arrival is our event A. And I'm going to say that international flight is our event B. All right. So let's record our test formula. Equals with a question mark. And let's figure it out. Okay, so my event A is late arrival. So out of a total of 180 flights, 18 of them had a late arrival. So this is 18 over 180. Okay. And the probability that the flight was an international flight, well, there were 60 of them out of 180. Equals question mark. And the probability of A and B. So the probability that the flight was international and arrived late, there were 6 of them out of the 180. Okay. And then we will pick up the calculator. $18 over 180. Okay, so I put in the left side, and I got 1 over 30. And, maybe by looking at this, you can understand that that reduces to 1 over 30. But what I'm going to do is I'm going to put 6 over 180 in the calculator to show you that when you do so, the calculator will reduce it for you. So once again, we don't really need the question mark anymore, right? Check mark on that. So therefore, these events are independent. So since this worked out, right? I'm trying to think how I want to word this. The events of being an international flight, the events of being an international or late flight. I'm going to run over here. Are independent. Right. And let's check out number 4. So looking at the two-way table, I noticed that I do have, again, my row total and my column total, so that's good. No extra work there. A farmer wants to know if an insecticide is effective in preventing small insects called aphids from living in tomato plants. The farmer checks 80 plants, and the data is over here. Is having aphids, I hope I'm pronouncing that right, is having aphids independent of being sprayed with an insecticide? So having aphids, I'm going to say, is my event A. And being sprayed with an insecticide is going to be my event B. All right. so there's my question mark. So the probability of event A happening. Well, there were 26 out of 80 plants. Probability of event B happening, 52 out of 80. And the probability of both those events happening at the same time, 12 of those plants out of 80. Question mark, right? So I'm going to pick up my calculator. 26. All right, so let's see the results. So I got 169 over 800. Oops. 169. So that doesn't seem to look like these are equal. And so what we'll do is we'll actually get the decimals for this one, right? So that's 0.21125, and 12 divided by 80, well, that's 0.15. So those are not equal. Therefore, this is a false statement, and that means that these events are not independent. They do have some sort of dependency on each other and therefore some influence over each other. So since probability of A times the probability of B was not equal to the probability of A and B, the events of having aphids and being sprayed with insecticide are not independent. Or you could say dependent. All right, there you go.